Welcome to a gentle introduction to SQL Server clustering. This webcast is sponsored by Idera Software. My name's Kendra Little, and I work with Brent, Ozar Unlimited. I'm a Microsoft Certified Master in SQL Server 2008, and I've been awarded the Microsoft MVP Award, which means that I like to help people understand how to get the most out of their SQL servers, and I talk a lot about SQL Server. I do a webcast every Tuesday. You can learn more about that at brentozar.com. And I like to draw, so I publish posters on different topics in SQL Server, and I'm excited that I've just launched a new poster on SQL Server Failover Clustering. So if you like what you see in this webcast today, go on over to brentozar.com/go/cluster and read more about SQL Server Failover Clusters and download a poster to help you remember the concepts that you learn in this video. Today you're going to learn about what pain points failover clustering addresses for people using SQL Server and how failover clustering can help you out, what it will do for you. We'll also talk about the problems that clustering doesn't solve and where you're still vulnerable, even if you're using failover clustering, and also why failover clustering is pretty critical to learn in terms of making sure that you understand some foundational tools that are used in new and coming versions of SQL Server for high availability and disaster recovery. So first, we are going to keep it simple. In today's talk, I'm really talking about failover clustering used in a single site with a single subnet. Know that the concepts that I'm talking about today, you can, with recent versions of SQL Server, make them even more complex. And once you learn the foundation and get the introductory stuff, you can then expand and make these things more complex. We are going to start pretty darn simple. To get started, let's just figure out, what does failover clustering help us with? There's some really basic core pain points to keeping SQL Server available and healthy and functioning properly that failover clustering addresses. Our data in our environment is very important. SQL Server holds databases that hold this critical data. And when we think about databases, we think of them in the context of a SQL Server instance. A SQL Server instance has user databases as well as system databases. And these system databases, which are master, model, MSDB, and tempDB, some of those system databases are used to hold things that you define, like who can access the SQL Server using logins, what linked servers might be defined in case distributed transactions are being used between SQL Server instances, what maintenance jobs are set up. All of that's contained within an instance container. We normally have, if we don't have failover clustering installed, if we just install an instance in a normal way, we have a SQL Server instance that's sitting on a Windows operating system that's on a physical server. So here you see there's SQL Node 1 is a server, and there's an instance that's just one instance that's sitting on that server. Pretty normal, right? The databases are available on the instance, customers are accessing the data, everybody's happy, things are working, things are moving along, applications are moving. Oh, we've had some security updates come out, and we realized, okay, we should apply these security updates to our Windows instance, because that's a good practice. We've done our due diligence. We've tested these updates in non-production environments, and we know that they're important. We want to make sure that our servers are healthy and protected. Well, we have a problem, because often when we apply security patches, we usually, and in fact, I always, after applying security patches, want to reboot the server to make sure that if any DLLs have been updated or anything like that, that Windows shuts down, comes back up, and all of the changes are made. Nothing's in a pending installation state. So even if reboot isn't required for a set of updates, you can bet that I actually want to do it just so I don't have any doubts about the state things are in. But the problem is, if I've just got this instance on this server and I'm rebooting it, my application is offline. While things are down, my users are no longer able to get to the database. Things aren't active. My applications are offline. That's kind of a problem. And I don't know if you've ever had this happen to you, but sometimes when you reboot a server, doesn't come back right away. Sometimes you're like, hey, did you even shut down all the way? Hopefully you've got something like a RIB card that's a separate card with its own network connection that you can log into and see the console of the server and say, hey, what's up with you? But sometimes you're sitting there waiting for it to come back up, and it can take a long time. Meanwhile, your applications are offline. This leaves us to doing things like plan maintenance maybe on the weekend, but in many situations, even on the weekend, if we're in a situation where things are taking longer than expected, many of our databases do have users around the world and processing needs where downtime on the weekend isn't even okay. So this can get really, really uncomfortable, not only for you, who's now burning lots of time on the weekend, but for customers. We also have the possibility that our server could go offline when we aren't planning it. There could be problems at the hardware level where things are going bad and causing things to crash. There could be problems at the operating system level, registry corruption, issues there, or we could just have something we want to update in plan maintenance. All of these things can cause outages, and a lot of times when we have failures, it doesn't always come in ones. So the pain point that we have is, wouldn't it be nice if our SQL Server instance wasn't so harnessed to a given physical piece of hardware and wasn't even so harnessed to a given operating system? Wouldn't it be nice if our SQL Server could be independent and could move around so that if there's a problem on that hardware or if there's a problem on that operating system, our SQL Server instance can be free and could roam about the environment? Yeah, that would be really, really nice. And this is the pain point that failover clustering addresses for you. It helps a SQL Server instance move around a cluster of servers. So if there's a problem on one operating system or one piece of physical hardware, your SQL Server instance can be a little bit free, right? Depending on how you have your cluster set up. Here's a really basic drawing of a simple implementation of a Windows Failover Cluster. This picture doesn't even have a SQL Server in it yet. We've got storage. We've got a networking environment represented by the box labeled switches, and we have two physical servers. We're going to call these nodes. One of them is named SQL CLU01 Node 01, and the other is named SQL CLU Node 02. Each of those servers has an operating system running on them, and you can log into Windows on their servers. They each have a name and IP address. They are both accessing that storage, and this is critical that they can both talk to the storage. This is key to the concept of the first failover cluster we're going to look at. If we install SQL Server on the cluster, and to do this you have to first configure the cluster in the operating systems on these guys. It's a very specific Windows feature that you enable the feature in the operating system, and then you configure and create a Windows failover clustering in there. And that sounds kind of like a big deal, but honestly, on recent versions of Windows, even on 2008 and 2008 R2, it's actually not super hard. There's things like a cluster validation wizard and report that'll even take a look at your cluster and do all sorts of tests on it and say, here's what looks good, here's what looks like a problem, and also here's what looks really, really bad. So lots of help from Windows in setting up the failover cluster there. Once you install a SQL Server instance on the cluster, which the SQL Server setup guides you through, you tell it, hey, I want to install on this cluster, and you've got to put it on all the nodes. And it says, hey, this is I see your cluster. Here we go. And it steps you through it. We here have a clustered instance. It's named SQL CLU01A/SQL A. Now that seems like a mouthful. I'll explain it in a minute. But the important thing to realize first is that it's that whole instance that's installed on the cluster, and it's going to stay together as an instance. It may leave Windows behind, it may leave a physical server node behind, but that instance stays together. And this is actually really handy. There are some technologies like database mirroring that take individual databases, and you don't get things like the agent jobs and the linked servers moving around. In this case, the whole instance, the whole family stays together, and if it needs to move, it will all move together. When you talk to a clustered SQL Server instance, it's a little bit different than talking to a standalone instance. you connect with what's called a network name or a virtual name. And this is a name and IP address that's specific to that instance of SQL Server. You also have what's called an instance name, and this gets a little confusing because I've said the word instance multiple times. The instance name is just like what's a named instance in SQL Server, even if you didn't have it on a cluster. Like you can have a default instance or multiple named instances on a server. And you actually do need both of these. This confuses a lot of people at first because they're like, why do I need both? The network name is the name that you assign that goes with an IP address that will move around with the instance so that it isn't just tied to the individual IP address and name of a single physical node, right? Because our instance can move. This is its virtual name or network name. And the instance name, which could be default, you can have one default instance per cluster. The instance name is really what you can think of as, how am I identifying this within a SQL Server family on the cluster, right? And it does need to be unique within the cluster. It goes with a port number. You can actually have multiple instances on a cluster all using port 1433, even if they aren't the default instances. That's actually okay since the port is tied to the IP address and everybody gets unique IP address. All the network names get unique IP addresses. You can actually have them all use 1433 if you want to actually use that for them. So we can access our instance in a way that's independent of physical hardware. That's the most critical thing to realize about this slide, is that the instance has a way you can talk to it that isn't just a physical node, and that's key. So let's look at an example. Time to install Windows updates now. Now I've got my SQL Server instance on a cluster. How is this different than before? Well, let's say that I'm a little naive, right? I might actually plan my patching in a complex way. What I might want to do first, if I was planful, is I might want to go ahead and install my patches first on SQL CLU01 node 02 and reboot it first. And let that sit there for a little while, at least an hour, to make sure nothing weird appears in the log. Hopefully I've tested them elsewhere, but maybe I don't have identical hardware elsewhere. So if I'm really smart, I'm going to specify my patching order in a specific way. But even if I don't do that, even if I'm kind of naive and one of my first steps is just, hey, I'm going to reboot node 01 to get the instance off of it so I can patch it, right? And maybe it's not you who's doing the patching. Maybe it's somebody else whose job is to work on the weekends and you're taking the time off. I send a reboot command to node 01 and Windows says, hey, okay, I'm going to shut down. It notifies our failover cluster, you know what? I got to reboot, I got to go down. You should really take this instance and, do something with it. And the failover cluster looks around and figures out, hey, node 02 is up over there. I'm going to go ahead and move this SQL Server instance to it so that people can continue to access it. That SQL Server instance starts to prepare to move, and it does this by shutting down the SQL Server services that are on node 01. The reboot starts happening. My SQL Server services shut down. During this period, you can't access the SQL Server, right? There's a transition period where my SQL Server instance is no longer on physical node 1, but it isn't yet up on node 2. And during that time, my applications can't talk to the SQL Server. If a transaction was open and wasn't completed at the time SQL Server needed to shut down, then that application needs to, hey, this transaction wasn't successful. I'm going to need to retry it. Once services get started up on node 2, my SQL Server services have come up because the failover cluster manager on node 2 said, hey, okay, start up the SQL Server services here. They start up, the system databases come online, master model, MSDB, tempDB. Even after that happens, I still need to recover my user databases. My user databases have to come online, and SQL Server for each of them has to say, okay, I'm going to look through your transaction log and figure out what transactions need to be rolled forward, what transactions need to be rolled back so that I can bring these databases online in a consistent state. Transactional consistency is super important to SQL Server. So we go through a period of recovery, and during this period, your application, it can't use it can't do writes to a database that's in recovery. It's in a state where it may not be yet fully online. One of the questions we frequently get is, how long will this period of failover happen? Take? How long will it take things to fail over? And the duration of that is going to vary depending on how long this redo undo process is, which in part is going to be due to the nature of what your application does, how heavy the workload is during the application, potentially the configuration of your transaction log, virtual log files, that type of thing, how frequently you do transaction log backups, when the last checkpoint was. Lots of factors play into that. So if you do this at a really busy time, failover could actually take longer. And on the weekend, you might still want to plan maintenance to happen on the weekend so that this downtime happens and recovery happens in a lighter volume time. After recovery completes, hey, cool, we are back online. Our instance is now on node 2, and note that my network name is still the same. I can still talk to my instance on SQL CLUO1A/SQL/A. That hasn't changed. My network name and instance name moved across the cluster with me so that all my connection strings are still the same. My applications are like, oh, there you are over there. I'm going to keep on going. And my customers are happy again. This is a really, really helpful feature. If I have sudden hardware failure, if I suddenly realize that I need to do something to one of the nodes in that cluster, or even both nodes, I now have a way that I can strategize. Okay, I'm going to test this first over here, and then I'm going to, do these steps to validate that it worked, and then I'm going to move things around, and then I'm going to do it over there. There are even tools that you can use to put variety of things in either maintenance mode or in a frozen mode to make them safer as well. So there's lots of things you can do to help make change and unexpected events easier. When you get to know failover clustering, one of the things you're going to get to learn about is Quorum. Quorum has to do with part of the logic about how different components in the cluster get to vote, right? Because there's ways that the cluster gets to decide, hey, where should this resource go? And should I stay online? In our current configuration, we might have a node and disk majority. Each of these nodes or physical servers, I have 2 of them here, get 1 vote, and then my storage get to vote. So that's a total of 3 votes. It's a nice odd number. If one of these members is down, like node 01 there, I've still got 2 voting members who are like, hey, I see you, hey, I see you, hey, we're good, right? As you look at doing more complex clusters, this starts getting more complicated. You can bring in things like file shares to start voting. You can do all sorts of fancy things depending on the number of nodes you have. And the good news is your cluster validation wizard will give you some advice about what makes sense, and SQL Server actually gives you some advice on some of its features about how it makes sense. So always know that you should research Quorum and that you should look at your version of Windows that you're using, as well as your version of SQL Server and the features that you're using, whether you're using just simple failover clustering or some of the availability groups features we're going to talk about later on. One of the really cool things that's happening is that current, meaning SQL or Windows, current meaning Windows Server 2012, and later versions of Windows, like the upcoming Windows Server 2012 R2, are introducing new features on how Quorum is done and how votes are counted when certain instances are offline that especially make a huge difference if you have larger clusters. So very, very cool changes are coming. And whenever you set up a cluster, thinking about how am I going to set up Quorum is key to understanding what happens if a component in this fails, because what the cluster does will vary depending on how many members you have and how many are online and how your Quorum is set up. There are many, many design options for clustering. And you can put more than one SQL Server instance on a cluster too. So here we have a 2-node cluster, node meaning physical servers. CLUO1 node 01 and CLUO1 node 02 are still our servers. We have the same number of servers here. We still have the switching, network environment. They're both still using the same storage, shared storage. So both of these guys can access this storage, but I have two SQL Server instances here. What is this like? I tend to get a lot of questions about this because people will ask a question like, well, if I install two SQL Server instances, can they somehow use the same database? And that question tries to get at what people are usually trying to ask there is there a way to kind of scale out reads and access the same database on two physically different servers of the cluster? The answer to that is no. What you see in this picture is you do see two instances. We have SQL CLU01A, and it has some user databases on it. We also have SQL CLU01B at the top. It has totally different user databases on it. Each of these instances will use its own LUN or chunk of storage. They are not using the same parts of that storage. They may well be using the same storage array or SAN or storage device to manage that storage, but they each have different chunks of the storage sitting under their databases, and their databases are unique. We aren't reading the same data on those instances at all. So we can have more than one instance, but they have totally separate databases on them, and they operate independently of each other. Each instance has its own logins, its own link servers, its own agent jobs. You've got to configure those on each instance. The reason that you would really want to do this, and the reason I find people are interested in this, is people want to use the hardware. In our previous example, we had two physical nodes, two physical servers, and we were only ever using one at a time. Sometimes people look at that and they say, you know, I'd really like to use that server over there. Well, there are some trade-offs to doing that. Yes, we can do this and try to get the most out of our hardware. In this case, we do have to buy an extra license, right? Each instance that we actively use, we need to license. The general big picture deal with licensing is that you can get one idle node for free. So if I just have one active instance on this failover cluster, I just need to pay for one license, and that license kind of moves with it, to one other node. So I can get one idle license for my instance. Now, if I have two active instances, I've got to actually pay for those. You got to pay for what you use. You only get kind of one freebie for instance. Right? And if you want more details on that, you need to look at the licensing white papers because it does get a little bit complicated in there. So now I've got two instances. I've got to license each of them. And often licensing is pretty expensive. Now the good news is you can actually use standard edition if it's the right fit for you. One of the myths out there is that failover clustering only works with enterprise edition SQL Server. And the good news is that's just not true. SQL Server Standard Edition does allow you to cluster. You can only use a 2-node cluster, right? I can't put it on an 8-node cluster. But to be honest, I might not really want to. When I design clusters, many, many nodes isn't necessarily fun for managing them. And the most common cluster implementations I see are actually clusters with two physical nodes. That's one of the most common ones out there. So Standard Edition can be clustered. Of course, there's other limitations that come with Standard Edition, so you need to make sure those work. So, but licensing is one of the more expensive things in my environment. So then you get into a situation where people are like, okay, so I've bought my hardware, that's expensive, and I had to pay for all this licensing. So I want to get a lot of use out of these instances, and they end up being really busy. Well, the problem with that is, let's say I do have a problem on one of my nodes and I need to keep it offline. Maybe it's an accidental failover, maybe it's planned maintenance, doesn't really matter. For the period where both of my instances need to run on a single node, if those instances are busy instances, this may not be so good for my customers. Maybe I'm online. If performance gets really, really bad, my customers may feel like I'm offline, right? If both of those instances use more CPU resources and more memory than Node 02 can provide both of them, it can get kind of ugly, right? So this situation of multiple instances on a failover cluster, it can be okay, but running all of my instances on hardware maybe isn't really an option in all situations. You've got to really be careful about how much risk can I tolerate for failure scenarios and what are the limits of performance that I can reach while, will my customers really be happy if we have to run like this for a day, for a week, for longer? can be a big deal. Clustering also doesn't solve every single problem that you have. It doesn't prevent failure in all sorts of ways. It will help you with many kinds of failure, but we do still have, with clustering, a single point of failure. When we have a failover cluster, your instance can move from one piece of hardware to another piece of hardware, but it's accessing the same data on that shared storage resource. The individual servers don't have a copy of the data on them, right? We have that shared storage, and wherever our instance moves, it's just starting up a SQL Server instance that's going and saying, hey, there are my databases over there. It's the exact same data, no matter which node you access it through. That's part of why it can be so fast. It only has to update one copy of the data. It's not like database mirroring or an availability group replica where it's syncing a second copy of the data. We have a single copy of the data, and therefore we have a single point of failure. So if something terrible happens, which we never ever want to happen, like, oops, a user accidentally deleted data in a critical table, or we had an attacker who compromised our application and changed a bunch of data or dropped a bunch of stuff, or we had data corruption, we've just got one copy of the data. We've got to have backups that we can restore from and operational techniques that we can help address these problems when they happen to us. Clustering doesn't keep these bad things from happening to us. If I have data corruption and I just fail my instance over to another node, I've effectively just kind of restarted my SQL Server, and in theory, it could make my problems worse depending on what type of corruption it was and where it was. At least it's certainly not going to get any better, right? It doesn't help us at all. Clustering is really critical to the future of high availability and disaster recovery. It's a really exciting thing to learn about because Windows Failover Clustering is pretty key to lots of technologies that SQL Server has introduced and is building on. Here's an image of an AlwaysOn availability group. AlwaysOn availability groups are built on a foundation of Windows Failover Clustering, but they don't necessarily work in the exact same way that the failover clusters we've been looking at are. So this image is a little different than what I've shown you so far, but it's still related to Windows Failover Clustering. Here we have two physical servers, SQL AG01, Node 01, and Node 02. And I did draw these to be a little bit bigger. I drew these as if they're 4U servers instead of 2U servers, just to kind of represent, hey, these have a lot of drives stuffed in them. So they have a lot of local storage. Because I don't have that storage element drawn separately here. We don't have separate storage here. Here, in our AlwaysOn availability group, what I have is Node 01. It has 3 user databases. 2 of them are defined in an availability group. These databases, they have their storage on Node 01. The data resides on Node 01, and the availability group is transferring data over the network to the storage on Node 2. And those databases that are in the availability group have their data flowing. As data goes into their transaction logs, it gets streamed over the network, and a second copy of the data is over on Node 02. Now, you might say, hey, this sounds like database mirroring. It kind of does. It's like database mirroring on steroids. Each physical node is a member of a Windows Failover cluster that's been built. And the cool thing about this is that the Windows Failover cluster, it's not doing the same thing with the shared storage here, but it is providing some other features like a listener and like its Quorum features. It has improvements over technologies like database mirroring. Database mirroring, the Quorum model was not so good. It was pretty limited. So we have lots of new options with failover clustering as the groundwork here. On our availability group here, I have my primary with the 2 databases in the availability group. I can access them through that listener who's represented here by the unicorn. And my listener can move around as things fail over. I can also do things like make some replica databases read-only. I can have multiple replicas. I can make some of them synchronous. I can make some of them asynchronous. And I can do all sorts of really cool things, all built on that foundation of failover clustering. So I haven't given you a full explanation of everything you can do with availability groups here. The main things to know are it's all built on a groundwork of failover clustering, and that it's really critical to learn failover clustering and all of its different permutations, because this stuff does get complicated. And you can make it complicated. Here's a picture. I don't want you to start here, but it's kind of interesting to know in terms of the places you can go. In this drawing, we have a Windows Failover Cluster like we talked about at the beginning. It's got 2 nodes. In this case, they've been named SQAG01, CL01. And you start to see that using short abbreviations for consolidated names can be really helpful, because if you were to use long versions, your names would be a mile long. So we've got 2 physical nodes that are in a failover cluster, and they're using that shared storage. So the instance that's in blue, like if SQL AG01, CL01, if that physical node goes down, it's going to automatically fail over to the other node there. Yep, it'll be offline while it moves over there, but it'll have an automatic failover, just like the scenario we described at the beginning. But at the same time that stuff is happening, I can also have that guy at the bottom, the green instance down there. It's a replica. It's an availability group replica. And in my case, it's asynchronous and read-only, and it's handling read-only requests for scale-out reads. And it can just be down there receiving changes as they come through and presenting them for reads while the primary instance is maybe failing over to another node in the cluster. Now, I say don't start here because as things get more complicated, the room for things to go wrong increases. Your high availability solution could be the main cause of your outages if you're not careful. If we lose Quorum, if there's a bug, if there's a race condition, if there's a problem, our instance may decide, oh, hey, I should shut down, right? If the cluster decides everything goes bad, maybe because of a configuration that we made because we didn't know exactly how to configure Quorum in the best way, or maybe because of a change that we planned in an incorrect way, or maybe just because of things beyond our control, then things can go offline. So we want to start in a simple way, and you don't want to introduce complexity that you don't need. You want to look at what is the environment that I really, really need, and where can I start to make sure that I can support it and that it's not more complex than I and my team can handle. Because your team needs to be able to handle this if you happen to win the lottery, right? I don't like to say get hit by a bus. I like to say if you win the lottery. So we learned a lot today about the foundation of clustering. Plain failover clustering. I'm a huge fan of failover clustering. It saves your bacon when things go wrong at the individual server level or at the operating system level. It really can make your life better when it comes to planning maintenance and just responding to those little things that can go wrong in physical hardware. It's great for that. We do still have storage as a single point of failure. So how we plan our backups, how frequently we take them, how resilient our backups are, and how fast we can respond to data being deleted, data being corrupted, that stuff is still super critical. Do know also it's tricky to pair failover clustering with some other technologies. I often get the question, what if I have a failover cluster that's all virtualized? And the answer is, well, technically that is supported, and technically it will work. But if you have problems with network communication between the nodes, things can start getting really, really wacky. If there's latency between the servers and the storage, things can get really, really wacky. When you do this, you've combined a hypervisor layer with the Windows Failover Cluster layer with SQL Server. So if you start having things like unexplained failover, sorting out exactly what reason it is for those failover gets really, really hairy. And you've got network administrators and SAN administrators and database administrators and sysadmins all arguing with each other. That's a pretty complex world when you're merging these things in with other complex technologies. Do tread with care. Don't start there either. We've also learned that the future of high availability and disaster recovery is grounded in failover clustering. So it's a super critical technology for SQL Server people to learn. One thing I didn't mention is many of the technologies like those replicas, if you have an availability group replica that does have a separate copy of the storage, certain things are a little easier. If SQL Server detects a corrupt page, it can say, hey, I've got a replica who has another copy of the data. I'm going to go out and see if I can grab the page from there and fix it up. Just like in database mirroring. Database mirroring has that too. So you have to be using a replica with separate storage. But if you're doing that, you've actually get some perks there in terms of corruption. Now, obviously, if somebody deletes a bunch of data from a table, it's just going to replicate that over to the replica. So it doesn't help you in every situation necessarily. We've also got evolving settings for Quorum in new versions of Windows Server that help us out in multi-node clusters with more and more nodes, and help do things like recalculate better if some nodes are offline. Reconfigures the population of possible voters, which is very, very cool. If you'd like to learn more about clustering, go to brentozar.com/go/cluster. At this address, you can get to a link to an article that covers lots of stuff about failover clustering with tons of Q&A at the end. The poster that I've just created on failover clustering, more details on why you shouldn't necessarily virtualize your cluster, as well as a great post that Brent wrote on why everything you know about failover clustering is wrong, which I think is a great post. Thanks for watching today's video, and join us again for a webcast soon.